welcome to a new Process Mining Café. Today our topic is automation, and many companies use or plan to use some form of automation technique, whether this is, for example, workflow automation or programming or robotic process automation to reduce manual labor. But which process can you really automate, and where is it better to keep a process with humans? So process mining can actually help with that by providing an accurate and transparent picture of the underlying process to help you make those decisions, right? This insight is needed to make those decisions. And to talk about this topic today, I'm very happy to be joined by two guests. So I welcome Erik Scroggs and Lloyd Dugan. Hi, Erik. Hi, Lloyd.
Hi, good morning.
Hey, thanks for joining us. Well, actually, Erik, you gave a presentation at this year's Process Mining Camp where you talked about how you're using Disco to analyze the RPA robot behavior at Serco, and it was so compelling and so much more to talk about this specific use case that we said, well, we have to invite you back and talk more. And along with you, we invited Lloyd, who is a chief architect at Serco and also a little bit of a mentor, right? Also aware of process mining and introducing the topic a bit many years ago. Again, welcome both of you for joining us here in the cafe. We're really happy.
Thank you for inviting us.
Now, before we get started, I just want to tell all of you there watching that you can participate. In the last session, Process Mining Cafe session, we had a problem with the chat platform that we are using. It wasn't working. Actually, it still isn't working, but Christian did some things to work around it. And so there's, again, the possibility for you to join the chat. You can do this just below the video where you are seeing this right now. There's a link that you can click on, and then you get to a separate window where you can type in a name, your name, or any name really, and then you're in the chat, and there you can add your comments or ask questions to Erik and Lloyd directly, and we will pick this up while we go along. All right, so now to get us started, I would like to talk a little bit about the background where you have been doing your work. So can you tell us a little bit about what Serco is doing, the company where you work?
Yes, and thank you for inviting us here. So the work at Serco for the program that we're on is in support of what is known as the Affordable Care Act, or ACA. And the ACA basically provides a means for those who are not employed or otherwise don't have access to employer insurance for healthcare to go on to the private market. The private market has certain minimum expectations for plans. So if one wants to go to the federal market exchange to see what kind of healthcare plans are available, they have to qualify for being able to do that. And so Serco is responsible for the back office processing of the applications to be eligible to do that. This is affecting millions of people every year, and these folks would not otherwise have access to healthcare insurance except through the unregulated private market, which is not very good, right? So the Affordable Care Act, also one time known as Obamacare, provides the ability to go to the federal exchange or to a state-sponsored exchange. Yeah. In this case, we're dealing with the federal exchange, and we process the eligibility of these applications in the background.
Great, yes. And maybe to paint the picture a little bit more, maybe Erik, you can also talk a little bit about describe just a little bit the process, the steps that are people taking who are working in this process at Serco.
Yeah. So the process is going to begin with the consumer whenever they have that realization that they're in need of health insurance, either for themselves as an individual or for their family. And so they're going to submit an application, and they can do that with either a hard copy that they mail into our mailroom, or they can go online and fill out a virtual application. But once we get that, we act as sort of the gatekeepers, and so we need to cross all the T's, dot all the I's, and make sure that all their ducks are in a row before we just let them loose into the marketplace and start shopping for an insurance plan. So we do a lot of verification work. That's most of the process, but there's a few other product lines as the application moves through the production line towards that end goal of getting them in the marketplace.
Yeah. Okay, and this is the more so this space of their different processes, right, that are in there, but that's the space where you applied Disco for your work.
Yeah, because we have millions of applications, millions of consumers, and so with just the sheer amount of paperwork that we're doing, we need to be able to track not just what's happening with any given application, but as a whole, we're trying to figure out where our production workers are spending their time, what they're doing with that time, and identify where we can drive more efficiency and squeeze that efficiency out of the process.
Excellent. Yes, and we will talk more about the specific use cases that you have worked with Disco in this context. But maybe before we do that, I would be curious maybe to take a step back a little bit and to talk about automation in general. So can you maybe Lloyd, maybe you can describe a little bit the automation journey that Serco has taken. How has maybe also the type of techniques that you're using changed over time? Can you maybe just paint a broader picture for us?
We are in our third 5-year contract for this. And basically, according to the lore that Serco tells itself, the opportunity to get into the technology aspects of this was basically handed to them because the initial launch of the healthcare.gov portal through which all this stuff was going to flow did not go off very well. So they needed some systems to ramp up quickly. Now, while we started off with sort of a .NET-based case management approach, which was very, very crude, the technologies we've added in over the last couple of decades in order have been case management, which we use Appian as the case management system platform. So we have a number of applications running on Appian. The core one, which is what Erik will get to when he gets to his material, is called TIPS, the Task Information Processing System. So it's built around organizing work as tasks that have certain attributes and characteristics that relate to the application. So the task is essentially a kind of facade to the application or the case, if you will. Mm-hmm. We've added in over the years decision logic to use the rules engine from Sapiens to automate the execution of business rules. And that is also powering dynamic work assignment, which is the thing that Erik is going to show, which integrates with TIPS in order to control the assignment of work. We have used RPA, Robotic Process Automation from Kofax, or now known as Tungsten, to automate virtual user sessions. And this has allowed us to optimize our workforce with the human workers because that was very expensive. So now it's a lot cheaper. We've cut it down from several thousand to 1,000 or so. Again, I think Erik will cover some of this in a moment. We are adding more in, right? We added Disco in to give us additional process mining insights into the task. We call it the task mining.
I'm curious about that. How did Disco come into the picture? So what triggered you to look into process mining in this context?
So, I've known about process mining for a long time. I've known you all for a long time and dating back over a decade, I think. So the discipline and the technology was understood, and I recognized the problem space. So I pushed to get a tool in that would allow us to do that without having to mount a hugely complex attack of SQL equivalent to pull the information together. It took a while to sell them on the idea, but they actually did, and now it's understood its value. So I knew that we needed something that could chain out the transitions of work and do it in a form that we could analyze. And Disco fit that to a T.
Yeah. Yeah, and Erik, you are the one doing most of the disco analysis, right? So do you want to add anything to that before we go into your 3 use case examples?
Yeah, Disco has been tremendously useful because when we're looking at our product lines, we have I think it's 19 different test types, and these test types represent the major product lines, so like verification, casework, expiration, that kind of thing. And then we also have several dozen tags. And so if you look at the matrix of test types to test tags, you get hundreds and hundreds of potential states for any given task. And any task it'll be bouncing around from one to the other, and so that lifeline of that task as it moves through the verification process, that's what we've been trying to analyze to see where the bottlenecks are, where the inefficiencies are, and try to get those corrected.
Yeah, that's a little bit the nature of casework, right? And case management system, that you have a lot of flexibility how to handle those cases. And you do have the digital traces that record what actually happened. And then process mining actually can be an opportunity to, without restricting upfront what people can do, to look at what are they actually doing, and is this the best possible way in which they can perform this work, right?
Right.
Okay, so I would say let's get started right away, and let's bring in, so you brought some slides that we can make visible here for everyone. To get started, here is a view of the process that you already described, but maybe can you walk us through again a little bit more what this process tasks are?
Yeah, absolutely. So if we start on the left, we can see that green dot. That's kind of the initialized state where the consumer has submitted an application. And at this point, all we have is the application. We have no documentation. And so when we run that checking all the consumer's data, if there's something that needs to be resolved or identified, what we do is we place an action call, which is exactly what it sounds like. It's a call to action to the consumer, and our work staff is trained to walk the consumer through specifically what their issue is that needs to get resolved, what kind of documentation can resolve that issue. And hopefully that'll prompt them to send in documents. And when we receive those in the mailroom, it's going to generate a verification task. And we'll get into the handle times for all these, but the verification step is really the big one. So at that point, either the documentation will be sufficient to resolve or it won't be. And so hopefully it'll be sufficient, but if not, it's going to generate an insufficient document call. So again, it's more outreach to the consumer, but a different product line. And again, the work staff is trained to walk them through the documents that they've submitted and just help them to identify if there's additional documentation or if it was illegible for whatever reason, a bad scan. And so these outreach efforts are really just designed to let the consumer know what needs to happen. Now that's at the ground level, but we also have different levels of training, different labor categories. And so if for whatever reason there's a complex issue that needs to be escalated, they can do that, and a higher trained, more specialized production worker will get that and work through the complex issues. We also, down at the bottom there, we have casework. And so we talked about how most of our communication with the consumer is outbound, but if they place a call to us, an inbound call, we really want to make sure that that consumer is able to get their issues that they're calling about resolved. And so that's where the casework comes in. And again, very highly trained, very specialized caseworkers will work those. So for the most part, these end up with the issue getting resolved, but you'll notice up in the upper right there, we have one last step for expiration. And this step comes into play when sometimes when we call the consumer and we ask them for the documentation, a lot of the times they'll say, maybe this will be easier if I just submit a new application. I'll correct the data that was wrong in the first place, and I'll just get enrolled in health insurance on a second application. And that's totally fine. They can submit as many applications as they need. But on our end, we still have that old application that needs to be adjudicated. Otherwise, people will come knocking and asking, what the plan is for these. And so as a very last step, if we absolutely cannot resolve the issue, we're going to run it through the expiration process, which is just a last-ditch effort, one good faith effort to try to resolve them. But if not, that application will be expired. And typically that means that there's a second application that the consumer is getting enrolled on.
Mm-hmm. Yes, yes. Okay, so that gives us an overview about the process that's going on, and that's you did mine this process. You put it into Disco. There was a huge, there comes a huge process map because there's a lot of complexity in the order in which how things can happen. But we wanted to focus here on this. In the first use case that we want to focus on is basically the evaluation of RPA agents, right? In this process, because this is the process where you have both humans working and you have robots working. And I think the robots are not calling people, right? Can you maybe talk a little bit about the distinction between these two types of resources that are employed?
Yeah, so we break up our workforce into the humans versus the robotic workforce. And the humans are much better at doing the more nuanced cases where consumer communication's involved. We don't like to do robocalls. Also, those escalated complex issue tasks. So the robots, they're not as specialized as a human worker would be, but they're really great at chewing through huge amounts of low complexity work. And so where we have them focused is on the verification and the expiration steps. And we find that typically a lot of the low complexity work there is tasks that our human workers don't like to do because they're tedious, they're trivial. And so by having the robotic workforce work through those, it frees up the human workers' time to do the more interesting cases.
Yes, and you brought some images also of the distribution of tasks for that, right? So if we go back to the slides, we can see for the humans, they do a lot of verification and handling complex issues, but they do everything really, while the robots mostly do verification and expiration, as you just mentioned. But then you were also looking at the robot behavior, right? So what were the things that you were looking at there?
Well, at first I was just looking at how much time they were spending doing what they're doing, but it occurred to me later on that we needed to figure out what they were doing with that time that they were given. And so we fed in not just where the tasks came from, but also where they were routed to, and fed that into the Disco tool to identify how many cases were able to be adjudicated with a single touch, which ideally we like to see as much as possible. If we can have a single task worked by a single user and then end stated right then and there, that's good for us. But we were able to identify by tracing through the application's lifetime, we can see what kinds of applications weren't as simple as just a single touch task, which kind of tasks had to bounce around from queue to queue to queue before they were able to get adjudicated. And so by comparing the human metrics versus the robotic metrics, we were able to see or identify where we needed to focus our efforts and to trying to drive that efficiency.
Yes, so that's also for those of you who are interested. So Erik brought also some visualizations here for those types of metrics, right? That's what you mentioned. Like, the blue is if it's completely finished in one step, is it that, or?
That'll be in the next slide. So right here, what we're looking at is just what they're doing with the time that they have. Mm-hmm. And so we can see right here, the verification step, like I said earlier, it's really the crux of the process. And so about half of the time for both robots and humans, half the time that they're working, they're doing that verification work. Right here is what you were mentioning.
Yes.
So if we compare the blue to the orange, this is the human metrics, and we can see as we go through the different queues, the more blue there is, that represents the single touch tasks, and then that's the efficient part. The orange bars at the top are tasks that, while value was added, we weren't able to completely, do everything that needed to be done on that task, and it had to be routed to a different part of the production floor. Yeah. And so you can see that first bar right there, where the most of the time is being spent. The y-axis there is measured in production hours. We can see for verification, where about half their time is spent. It's about 2/3 of the time they're able to, get it knocked out one and done. But that last third, that orange bar right there, represents areas where we can potentially look at why was this task not able to be worked completely? Why did it have to be routed to another part of the production floor?
Right, and this is the humans, so we can look at the same thing for the robotic workers, and yeah, it looks a little bit different.
Yeah, you'll notice that there's a huge orange chunk right there in that first bar, and again, this represents the verification work, where about half the time that the robot's circuits are firing, this is where they're working. And so seeing that much orange, it tells us that if we really wanted to drive the efficiency of the robotic workforce, verification general would be a good place to start training them up and figuring out what were they unable to accomplish on these tasks and how we can train them to work those. And so as we go on and improve our automation, ideally I'd like to see the blue bar get bigger and the orange bar get smaller.
Yeah. Yes.
So I think we need to, the word train the robot is a bit weird.
Good point, Lloyd.
What we're talking about is programming it to take on more diverse characteristics of the task so that it can successfully complete the work. What we deal with literally hundreds of interacting business rules, each with its own effect and its own set of peripheral effects with other rules that make this problem very dicey. So the expansion of what we call the yield of the robotic work to be done is eating into the orange, right? Expanding the blue by eating into the orange. So when we say train the robot, what we really mean is program its behavior so it can deal with more complex and diverse situations. And this kind of insight is what helps us to do that.
Yes, very good point. Yes, and also Erik, you mentioned that it's so big of an orange chunk in there, it doesn't mean that it doesn't add value, right? Even if they're contributing a little bit in the process and then kick it back to a human, it's still, that piece is something that the human didn't have to do, so it's still helping.
Right. Yeah. The orange bar by no means represents a total waste of time. And in fact, whatever actions they were able to do, they're going to do that work 10 times faster than a human would. And so, like I said, it's not a complete waste of time. There was value add to the task, and it's beneficial to have the robots get those first touches on the task, because whatever they're capable of doing, they're going to knock it out. And that's just, that many fewer things that the human worker that follows up has to do. Yeah. So hopefully simplifies the whole thing for the human worker.
Exactly. And I mean, this is all a little bit on the statistics level, right? So some of the process mining viewers might wonder, well, where's the process mining in that? You're right so far. But that's also why we asked Erik to share concrete examples where we are getting to this point where then based on that and all these insights, Erik was actually really analyzing the process flows and how robots and humans were processing all these different tasks. And this is where the actual process mining and the analysis of the behavior, beyond just overview statistics like this, come in. And so in the talk for the process mining camp, where you can sign up to be notified once it's there, Erik goes into much more detail, but maybe just briefly, can you talk a little bit about this particular example where you found some inefficiencies for the robots working?
Yeah, this was a really exciting discovery, because when I was first learning the Disco tool, I came across the cases tab, and my first instinct as a data science nerd was to look at the statistics and get those numbers and facts and figures. But the cases tab is really interesting because if you understand the underlying business process, you can almost read these cases like a story. And so if we go back to that example there, we can see in this example here, so this is one variation, and I've filtered away all of the variants that didn't follow this pattern. But essentially what we're looking at here, from top to bottom, we can see in the resources column, that very first worker is RPA, that's Robotic Processing Automation. So this is one of our robotic workers. And they got the first touch on that task, which again is a good thing. We want the robots getting that first touch. And we can see on the very right there, on the right side, that's where the task was routed to. And so if you remember what I said about the types and the tags and that matrix of queues, we can see that the robotic worker picked up verification general and routed it back to verification general where it got it from. Because, again, this is one of those orange bar moments where it provided some value, it added value to the task, but ultimately couldn't do everything that needed to be done. And so it stuck it back. Next up, we have a human user on row 2. And I've redacted the people's names just for anonymity's sake. But we can see that the human user was able to complete the rest of the verification work, and then they routed it into a call tag, the AM call tag. Now, at this point, while the task is sitting in the call queue waiting for a call center worker to pick up the task, we had what we call a system new doc reset. So while there's an active application in our queues being processed, our mailroom received a second document from that consumer. And so the system goes in here, and you can see the resources of the system. And because of that new document that requires verification work, the system pulled the task out of the call queue and stuck it back into the verification general queue so that we could do that verification work. And then we see in row 4 there, the final step, there was another human user, and they grabbed that verification task. And in this case, the document was sufficient to resolve. And so we can see the type 2 and tag 2 there. It was an end state. And so that's kind of the start to finish, the whole life cycle of the application. But what I noticed was, again, using the cases tab and reading this as a story, what immediately jumped out at me was that after the system new doc reset, it's essentially a brand new verification general task that requires processing on that document. But if you'll notice, it's a human user that got that first touch on the task after that new document came in, whereas before we had the robotic worker getting the first touch. And so I asked myself, why is a human getting a first touch on this brand new document instead of a robot? And so once we used Disco to filter away all the variants that didn't fit this pattern, we were able to troubleshoot and identify exactly where the issue was. And in this case, it was just a single Boolean 0 or 1 that wasn't getting reverted with the system new doc reset. And so the system thought, this task has already been looked at by an RPA, needs to be looked at by a human. When in reality, it's a brand new document. We really should have had that robot getting the first touch on that new document. And so this is where Disco is really, really useful. You can kind of filter away all the stuff you don't want to look at and identify these problem areas and really use it to narrow your focus down on what the issues are. And it helps drive that troubleshooting.
It's very nice. Thank you for sharing this example. And it's closing the loop to what you were saying before, Lloyd, right? Because if you're analyzing the actual robot behavior, then you can see where the gaps are. And then ultimately you can adjust configurations or the programmings to improve it bit by bit over time.
Yeah, I mean, we need to understand just how small a needle this was in a giant haystack of information that the tool allowed us to find. Because when we designed the RPA, the thinking was, the RPA gets the first crack, and after that, it has to be a human if the RPA can't close the loop. It never occurred to us to realize that with this document reset function, it essentially restarts the clock on the work. And that should have told us that we should let the robot get another crack at it, but we didn't do that. It was a small detail to overlook in the RPA design. But and it went undetected until Erik just said, wait a minute, what's all this about? So again, this was a very small functional needle in a very large haystack of information that we would not have found without this code.
Yeah. Yes, and that's such a nice example for what process mining can do with its explorative work, right? If you don't yet have the question or you don't know yet what you're looking for, exploring the process, looking at it, is this what you expect? And just noticing things that aren't right or could be better. So yeah, that's what process mining is really excelling at. So thanks. So this was the first use case. To give you an example, if you're having maybe your own RPA robots or any similar scenarios, how you can use process mining to analyze that. The second use case was turning it around, right? I understood from both of you, you didn't start with process mining before you started the RPA projects, but in a later stage, you did use your insights from Process Mining to decide where to employ new robots next, in which process and which task.
Yeah, so we had a few ideas of which product lines might be useful to start automating, but what we didn't know was how much value we were going to get out of those efforts. And so what we were able to do is feed in the human data for these different product lines, and we were able to calculate over the course of an entire plan year how many human production hours were spent working these product lines, and if we were to automate those, giving a parameterized value for or how efficient we assume that the robots will be, we can see exactly not only how many production hours we'll be saving, but how much bottom line, bottom dollar savings we'll have by not having to pay that human overhead and the salaries and benefits of a human worker, because with the robots, we're just paying the electric bill, and so it's much cheaper. But being able to drive that bottom line value for how much we're saving is tremendously useful for helping us prioritize where we want to focus our automation efforts.
Yes.
And just to add a little bit on to that, right? So we would have been moving to RPA as the answer here for what Erik uncovered, but we're actually going with an alternative automation approach where it's all a headless case management moment, right? There's no user interface involved at all. We're currently building that out. We'll be deploying later this year our first iteration of that. So, but it is the tool by which we validated the choice of work stream to so automate. And like I said, if we weren't doing that, we would be putting it behind RPA. But instead, we're choosing a somewhat different path for this one. But I got to emphasize that the information that was assembled was packaged into a very large Excel spreadsheet with pivot tables and nice graphics, some of which you've seen in this presentation. And it was all cultivated from a year's worth of data, plan year data, going into Disco. And correct me if I'm wrong, Erik, but that was well north of 10 million records, or how many million records was it?
Yeah, I think it was in the hundreds of millions. It was pretty substantial.
A good chunk of stuff was processed.
Yes, and you brought a picture of that also, right? Some of the piece of the Excel sheet that ultimately you built from that. Let me go to that slide if you can see that here. So that's where you said, right, you can then actually play with some of the parameters for assumptions, like how fast, for example, is a robot able to do this, and what would be the benefit for that?
Yeah, we can see down at the bottom there. So these are the hard facts and figures over the course of 2023 plan year, what the end state results were for the humans working, in this case, RADP tasks or remote identification proofing. And so at the bottom there, you can see RADP is a pretty straightforward product line. And almost 97% of the time, it's just a single one and done. We verify the document and then you end state it. About 3% of the time, they're sending it back into the verification queue just for follow-up work because there's something that wasn't able to be completed. And then less than 0.25% of the time, they're being escalated for complex issues. So those are by far and away the most extreme edge cases. But if we assume that the robotic workforce is going to have the same success rate, then we can calculate how long or how much quicker the robots will be working than the humans. But because we don't have that data, I wanted to leave it parameterized. And so in the middle there, those yellow boxes, that's where I made an assumption that robots would have this same success rate. But you can move that value up and down, and it'll adjust the calculations, similar to where we can see on the left there, the human workers on average spend about 7.6 minutes working these. I made a guess because, again, I don't have the data to back it up, but we parameterized a value of 5, and we can see that assuming that the RPAs take 5 minutes to work these, and with the same success rate, we can see that they're working these tasks about 5,000 hours quicker over the course of a year. But not only that, the 16,000 production hours, again, that's where we're spending a lot of overhead, just keeping humans working at the site and producing these, whereas robots just kind of quietly work in the background and we don't have to pay them.
Right. Yes. Okay, so yeah, just to recap, the first use case that we discussed was analyzing the robot behavior and looking at the interaction between those. And the second was identifying automation opportunities regardless of which type of automation you're doing, right? Lloyd, like you said, instead of RPA, you're doing some other form of automation now, but yeah, it's the same thing. So with process mining, you can look at the real process and then see, okay, where can we actually get most out of it to automate that piece of the process. So these are two different use cases, but you also brought a third use case, which is brand new, which I understand. So should we move to the third example?
Yeah, that sounds good. These are those last slides that we added?
Yes.
Yeah, absolutely. So here what we're looking at is the training progression of our production workers. So when we hire a brand new worker, they're going to start off getting that baseline introductory training where we get them on board and everything. But we have a core work staff, and a lot of them have been working here for years. And as they work through their career, they're going to be receiving training. And assuming that they pass their certifications, they'll be assigned what we call training badges. And every training badge is going to make them eligible to work a new product line. So before Disco, we did a while ago try to quantize these training paths to identify in cohorts which progression of training badges these workers are going to receive and in what order they're going to receive them in. But what we found was that it was almost impossible because a lot of the training was being received very ad hoc. Maybe we need more case workers, and so they'll grab a few production workers, get them trained on casework. Or maybe we need, whatever product line just happened to be in desperate need. We just grab a bunch of people and get them trained up. And so that ad hoc training, it really it kind of confused the whole training path process. There was really no defined set. What we realized after the Disco tool was that we can feed in, because we have those time and date stamps of when they get certified in different product lines. And so it occurred to me we can feed in that training data and see what's actually happening in production. What are these workers actually doing? And from that, we are able to narrow down these training paths and actually define specific paths that an ESW or a production worker could follow. And so it was incredibly helpful to really define these training paths that production workers can go down. And now that we have it, we can identify and classify different production workers and use that for our projections into the future.
Yes, and what I find really interesting about this application is that, we are really talking kind of about an additional dimension, not just the process flow dimension, which often process miners think of when they think of a process, but this resource dimension, of course, in a real process, in such a resource-intense process like yours, is absolutely crucial, right? So the way how work is assigned to whom, and then you need to match the work to their level of competency in the most optimal way. So this is a whole optimization problem that you're dealing with there.
And the core, one of the core functions of dynamic work assignment, which is what is informing most of the stuff you're seeing, which is what controls the assignment of tasks to workers, whether they be human or robotic, is are they qualified to do the work, right? So we actually give the RPA users badges so they run through the same qualification process that a worker does. So the badge reflects that the programming has essentially trained them into what they need to do. But without that, none of this would work. And when the training has such diversity and permutations and outcomes, it makes it hard to sort of see how the workers aggregate into different resource pools, which then allow us to make the assignment based upon how much work is there, and who's qualified to do it, and so on and so forth. So yeah, we've had to overcome a number of optimization problems, and Disco has helped us do that.
Yes, great. And so if I understand you correctly, Erik, you then took those, basically the logs, the training timestamps of who got trained when for what, and then you looked at the process flows with Disco to see, are these the actual training paths that we are expecting, right? And I think you made some different groups. So is this different levels? Like, for example, this GC2, GC3, are these kind of different groups of?
Yeah, so GC stands for General Clerk. So these are different labor categories. We also have bilingual specifiers. So there's different labor categories. But essentially, we have the 2-level work and the 3-level work. And the GC3 level work is going to be the escalated cases, the complex issues. And so we can see here that Disco screenshot. Each one of those course codes, they're a little bit hard to read, but they reflect a training badge that got an ESW trained on how to work a specific product line. And so rather than just having this huge mess of kind of ad hoc, you have some subset of these training courses, we can actually see where the bulk of the production workers, how their training evolved over the course of their career. And so going back to what Lloyd mentioned about the resource pools, the overall goal here is to be able to take a worker, look at their not only their labor categories, but also the specific subset of training badges that person has. And we want to be able to encode all of that information into a single value, a resource pool. And so if we take a look at that very last slide, using the Disco data, we were able to come up with a total of 29 different resource pools. And so if we have, let's say, a GC3 and they're in resource pool 29, that means that we've received all their training. They're trained and capable to work anything you can imagine. So those are what we call the everything pizza ESWs. But by quantizing all these ESWs into their resource pools, just by looking at that value, let's say resource pool 17, we know for a fact that person has been trained in casework, RADP, DHSAVE, and MLP. And so it's a lot easier than having to reference an entire list of training badges and their resource pool and all this other data. It's all compiled and encoded into that resource pool identity, which is very useful for figuring out how much of any given resource we have. So if we have a bulk of one kind of work coming down the pipeline and we need to target down that mountain of work, we know exactly which resource pools are capable to tackle that mountain of work.
Yeah.
So very useful for projections.
Yes. So and just to make sure we all understand it correctly. So in the process map, right, you had people were going through those different steps. Each step gives them a training badge for a certain capability. But of course, when they go to the second, the third one, they still have the capabilities of the previous ones that they already earned. So in that sense, it's cumulative. And if you're looking at the variance in this case, in this sense, you could come up with those pools where then maybe in different orders, but people kind of add new training badges, and then the more they have, the more capable they are, the more flexible they are to do that work.
Right. Yeah. I noticed, again, after feeding all this into Disco, one thing that jumped out was that for the lower level, the General Clerk 2s, they typically do follow a pretty linear training path. And we were able to identify a few outliers, but for the most part, 99% of the time, they're following a very strict progression, training badge 1, 2, 3, 4. And so you'll notice that the GC2 training paths, it's very short. There's only, I think, 5 resource pools there. With the GC3s, though, because the work is so much more diversified, instead of a single training path, it's more like Plinko. As you get more training, you're bouncing around. You might go left, you might go right, but eventually you're going to get down to the very bottom where you have all of the training badges. Mm-hmm. And so the idea behind the GC3 training paths is that it's not so much a linear thing, but no matter where you fall as you receive your training badges, you're going to be generally working down that list until you get to the very bottom where you've been trained on everything.
Right. Yes.
So we had an aspirational representation of training paths earlier, which turned out not to be very reliable. Right? This is what Erik was hinting at the beginning of his discussion of this scenario, of this set of use cases. What DISCO is giving us, though, is a picture of the actual. And that tells us we can go to the training department, for example, and say, well, this is probably the path you want to follow because we can streamline this further, or we have to diversify this in some manner. But it gives us a basis for making that argument that would have been impossible to do without the analytical material that DISCO produces for that result. So it wasn't just that it helped us do the resource pools, which is to help dynamic work assignment, but it helps us to have a conversation with the training department about what is the most appropriate set of paths and badges to see. So we can't ever get to the point of a cohort set of people moving progressively through the paths, but we can report on where we are with respect to the aspirational path and make adjustments accordingly based upon what that gap is.
Yeah, thanks for pointing that out. It's the discrepancy between, maybe aspirational or what's documented and what's the reality, right? And you can move from one to the other using process mining.
Yeah, and the great part there is we no longer have to try to convince the training department to adopt these new ideas. We can just go to them and say, this is what's already happening. Now we just have a definition for these training paths. So it really does help drive that conversation with our training department.
Yeah, so you use it as a communication means to show them the maps really, and they can see the flows, what's going on.
Exactly.
Yeah, and also I understood that you're also using this, it's a plan of yours to use that in one of the next steps to do projections, right? So we talked in other process mining cafes, we talked about simulation and how simulation is complementary to process mining if you're looking into what-if scenarios. But one thing that you really need to be able to do this is an accurate as-is current state descriptions. So that's what process mining can help you to extract. And I understand for the work assignment stuff, that's basically what you have been working on here to be able to take this next step.
Right. Yeah. We can kind of have a general idea of what work is coming down the pipeline. But what we really needed to do was to understand for any given day, how many of any given resources do we have available at that moment. And so by refactoring these resource pools, we know exactly, like, let's say there's a huge mountain of exploration tasks coming down and we need to tackle these. Now we have an exact number of, out of our entire workforce that has shown up on this day, we know exactly how many are trained to work that exploration load of tasks. And so it's very useful for if we need to be able to project out and say, okay, if we assign, so-and-so group of ESWs to work in these group of tasks, we can make a projection 24 hours out into the future and say, okay, given this state with the resources that we have available, we're expecting 60% of this workload to be worked within the next 24 hours, just for example.
Right.
We have to pay attention to this stuff because we operate under a set of service level agreements, SLAs, as well as internal quality of service metrics, KPIs, if you will. And so all of these things are affected by how quickly work is assigned in the most optimal fashion. So it gets, as we say around here, the right task to the right person at the right time. Mm-hmm. So our imperative here is that we have to make sure that we don't run afoul of these agreements, these SLAs and quality of service levels. So because those do have consequences for us, negative ones, right? But we haven't had an SLA problem in a long time now. So we're just trying to stay on top of it because of the ever-changing nature of our work set, because every year more people have been joining in through the ACA program. So this now, relative to 10 years ago, for example, he's dealing with millions more tasks to work, millions more people seeking coverage. So it's only going to get more like that over time.
Right.
Yeah, I remember back in the early days of the contract, we had a pretty simplistic first in, first out queuing system. But what that meant was that if you had a less urgent task be generated, and then after that a super critical urgent, like a casework task, we really needed to be able to identify, where these tasks need to be, maybe pushed up in terms of their priority to the top of the stack so they could be worked sooner, as opposed to just, in the order we received them in. So yeah, using process mining, it's been really useful to help drive that.
Yeah, no, that's such a good example and a really essential dimension in a process that's often a little bit overlooked. So I'm glad we got to talk about this a little bit more. So this has been excellent. So we have been talking about 3 different use cases, using process mining to analyze robot behavior, finding ways to make them work better together with the humans, looking at how automation opportunities can be identified. And then the third use case was analyzing the actual training flows to inform the actual training path, but also to use them as a starting point for projections, for example. Do you want to add anything that we forgot, or that you also wanted to mention?
I think we hit all the bases that I wanted to cover. But Lloyd, do you have any final thoughts over any of those?
We are going to be in the coming years incorporating AI and ML, artificial intelligence and machine learning technologies, and I think there's the beginnings of a data science practice here that is largely attributable to both the Disco tool and Erik's own efforts to extract value out of it. So I do see going forward that we're going to better understand the role of process mining in the larger pantheon of data science, and it will be joined there by machine learning algorithms that allow us to interpret meaning out of the data we have. So it gives us a leg up on something that's very central to what we do, but it's only the beginning of our journey into this new realm.
Yeah, that's a good point. It's really very complementary, of course, yes. So I'm sure there's a lot of interesting things we're going to see. All right, maybe, those of you watching, if you have another question also for Erik and Lloyd, you can put it in the chat now. I have one last question I want to close by, and it's a more general one. So what I've observed a little bit over here in Europe, people are often a little bit more maybe skeptical or looking, talking about the ethics of automation, so that it has a little bit of a bad reputation, perhaps, like people are afraid. Maybe also it's one of the dimension, maybe partly it's cultural, but maybe being afraid of being replaced. And so how do you look at that? So you have reduced the number of human workers at Serco, but what kind of work was that? Do you think that the people who are working there, do they have better jobs now? That's often something that's claimed, right? That automation takes away the tedious work. How do you look at these kind of ethical questions?
I think that, we have the knowledge worker that's left, right? So what's left is a more empowered knowledge worker, more focused on the more complex stuff to do. So those who will be trained up, right, through both or get the experience to supplement that training, or vice versa, right, will be the beneficiaries of this area. But there's no question that the simpler work has now essentially been farmed out to automation. And there are, obviously some ethical concerns about that. But we operate under a contract. It's a competitively bid contract. So there is an imperative to optimize the cost of the services being provided to the federal government. So I don't think we need to apologize for that, but it is just the brutal reality of the nature of the market. With respect to the fear of automation, though, we definitely have encountered that. I'll let Erik give any stories he wants to on that one, but that's not a unique thing overseas. We have all sorts of fear-based reactions over here that we contend with all the time.
Right.
Yeah, I can say because I spend a lot of time troubleshooting IT trouble tickets. And one of the things I see quite often is when dynamic workforce assignment gives a highly skilled, highly trained production worker a really low level, tedious, boring task, they don't like it at all. And even if the system is, working correctly, that it is a task that needs, human eye-brain system working on it. They really don't like those tedious tasks. And so, with the automation efforts, what I've seen is that when we're looking at our workforce. Okay, so for context, we kind of have two different types of production workers. There's our core group, and these are our full-time career ESWs, and they work 365 days a year, they work throughout the year. They do have time off, but we also have seasonal ESWs, and they come in on a contract that might last for 6 months. And so they know when they're brought on that job is only going to be there for 6 months. And so these will be our lower level, not as trained production workers. But what the automation effort has been doing is it's been driving down the need for those seasonal contractual workers and really helping us to focus on training up those core production workers to make them more career ESWs as opposed to just seasonal contract workers. And so it really does, I think, help to kind of focus in our humans into more of a career path rather than a contractual, case by case, year by year type of employment. So I think overall it's a good thing.
All right, great. Thank you both for your take on that. I really appreciate it. Thanks so much for coming on to Process Mining Café. Thank you all for watching. We will be back in about a month, and then we will be talking about data pre-processing, one of the core topics for process mining. So thank you both. Thanks for coming.
And thank you for having us. It was great being here.